Okay, here's what is available for you on the Unit 3 review. You have a Unit 3 summary, you have, and this is all in Blackboard, you have some extra practice problems, you also have for voting, and when we talk about that, you'll see the voting practice sheet. And also there is the review from the department. So we're going to do the extra practice problems together, but it doesn't cover everything, just the things that I think need the most review based on what I've seen in the past and what you guys have provided for us. Okay, so probability and expected value, these all go together, and along with expected values are actually in with probability, it talks about the law of large numbers, and we're going to do a problem like that. I really didn't put it on here because it's basically the relationship between relative frequency and theoretical probability. The larger the sample, the closer the relative frequency probability should get to theoretical. Notice the word should in there. Okay, so in probability, you're going to need to know the difference between the three types. You're going to need these formulas, but you won't have the names. So all you will have is this information right here, and you will need to know when to use which formula. A probability distribution table, it lists all the probability of all possible events. And so if you have all possible events, the total is going to be 1. So that's a good way to check yourself on those. The multiplication principle we know. And then odds. The notation, there are 3 notations here. The odds for and the odds against. And once again, you will be given the formulas, but you will not know what they mean. Okay, so let's do probability, and then we will go and work on a voting theory problem. Okay, so probability. This covers us finding the probability. It finds us finding all the possible outcomes and completing a probability distribution table. So, the weather forecast for a 3-day weekend holiday shows a 30% chance of rain each day. Assume the chance of rain each day is independent. And that's huge, knowing whether something is independent or dependent. That means it doesn't matter if it rained on Friday. That has no impact on whether or not it rains on Saturday. Same thing with Sunday. So they are independent. All right, so if you randomly pick one of the 3 days, what is the probability that it will rain that day? Well, there is a 30% chance of rain each day, and the 30% is the same thing as saying in probability 0.30, because remember, all your probabilities have to add up to 1, so your probabilities are all going to be between 0 and 1. So this is 0.30, and we're going to just call that probability of a rain. Okay. The probability of it not raining, remember to find the probability of something not happening, so the probability of no rain. Remember, the probability of not E equals 1 minus the probability of E. So this is going to be 1 minus 0.30, which gives me 0.70. Now, what are the odds that it will rain that day? And of course, the odds, if it just says odds, that means odds on. So that is going to be the probability of rain divided by the probability of no rain, which is going to be 0.30 divided by 0.70. And if you do that in your calculator, and it turns it into a decimal, this is 0.42. Okay. But everything we need is going to be right up here. The first thing it asks us is here, how many possible combinations of rain, no rain are there for the weekend? Okay, well, for each day, we're going to be looking at day 1, 2, and 3. So we've got day 1, day 2, and day 3. Well, day 1, it can either rain or it cannot rain. Since these are independent events now, once it is rained or not rained on day 1, it can either rain or not rain on day 2, rain or not rain on day 2. And then on day 3, it can either rain or not, rain or not, rain or not, rain or not. So the combinations, if we just follow our tree, are rain, 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 no rain, rain, no rain, 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 no, 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 rain, rain, no, rain, no, 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 rain, and no, no, no. Okay, so those are the combinations, and if you add them up, there are 8 possible combinations. Now, you could use the multiplication principle to do this as well. If you just wanted to find out how many possibles there are. For day 1, there are 2 options, times 2 options, times 2 options, so there are 8 possibles. But we wanted to know what the combinations would be. All right, so now, each of those 8 combinations is going, the only possibilities are 3 days of rain, 2 days of rain, 1 day, or no day. Okay, so the 8 combinations have to fit into one of these categories. Okay, well, the only way to do 3 days of rain is just rain, rain, rain. And if I do rain, rain, rain to find the probability, this is the same thing as saying the probability of rain times the probability of rain times the probability of rain. Since they are independent events, and it's an and statement. This is rain and rain and rain. So we're going to find that probability, which is 0.3. We got that from above. So 0.3 times 0.3 times 0.3 gives us 0.027. So that is the probability that you will get 3 days of rain. For 2 days of rain, we have to find on here the combinations where there are 2 days of rain. Here was the day with 3 days. So for 2 days of rain, we have 2 days here, 2 days here, and 2 days here. So the combinations are rain, rain, no rain, rain, no rain, rain, and no rain, rain, rain. So now we have to find, since there are 3 combinations, we have to find the probability of each of these. So the probability of rain, rain, no rain, well, the probability of rain is 0.3. The probability of rain is 0.3. The probability of no rain is 0.7. And when I multiply those together, I get 0.063. Okay? For the second one, the probability of rain, no rain, rain, 0.3 for rain, 0.7 for no rain, and 0.3 for rain, and again I get 0.063. Notice these are the same, because since they're independent it doesn't matter, I'm just changing the order of them. And then the probability for rain, rain, no rain is going to be the same thing, because it is 0.3. I'm sorry, this is no and rain, rain. I am so sorry. So that's 0.7 times 0.3 times 0.3. Now to find the total that goes in here, I'm going to add these three. And when I do, I get 0.189. I'm going to do the same thing now for 1 day of rain. For 1 day of rain, if I look back on my possible combinations, I have rain, no, no. I have no rain, no. And I have no, no rain. Okay? So I just have to find the probability of each of these events. And notice there are 2 no rains and 1 rain in each of them, so it's going to be the same. So if I have the probability, excuse me, of rain, no, no, this is going to be 0.3 times 0.7 times 0.7, which gives us 0.147. The no rain no is going to be these three numbers in a different order, so it's 0.7 times 0.3 times 0.7, which again is 0.147. And then finally, the probability of no, no, and rain is the same thing. It is just 0.7 times 0.7 times 0.3. Then when I add these three numbers together, I get 0.441. Okay, and then the probability of 0 days of rain, that just means no, no, no. There's only one possibility there. So I need to find the probability of that, which is going to be 0.7 times 0.7 times 0.7, which is 0.343. And again, to find my total here, it should equal 1. If I add all these up, and in fact when I do, it equals 1. Okay, let's go ahead and look at a bag of marbles. So we've got a bag that contains 8 blue, 12 red, 9 green, and 15 yellow marbles. Okay. I am a very visual person, so I just drew some marbles real quickly. Okay. And of course, the first thing I want to do is find the total in the bag. And if I just add all these up, it's 44. Now that's really important to know because that is the total possible outcomes. If I draw a bag, I have 44 different ways that it can come out. Okay, so what is the probability of drawing a red marble? So the probability of a red is going to equal how many reds? So there are 12 reds out of the total 44. Now you're welcome to leave it just like that. Okay, it can be reduced, but you absolutely don't need to. Both those numbers are divisible by 4, so it reduces to 3 over 11. Okay, the next one was, what are the odds of drawing a green marble? Okay, well, odds means the probability of a green divided by the probability of not green. So the probability of a green, there are 9 green and to find not green is just equal to our total minus the green, which gives us 35. So it's just 9 out of 35.